Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we gave the intuition for the level log model, which was a 1% increase in x changes y by approximately beta 1 over 100 units. So now we're going to prove it mathematically. And we're going to start as usual from the population model, which is y equals to beta 0 plus beta 1 ln x plus some error term. As usual, we're going to assume that the conditional expectation of the error term on x is equal to 0, which means that the conditional expectation of y on x, then we can rewrite it as simply beta 0 plus beta 1 ln of x, because the conditional expectation on the error term, that's going to disappear. So this is the regression function. Now let's compute the marginal effect. Any changes, so derivatives on the expectation, this function of y on x with respect to x, we're going to do it as the derivative with respect to x on this entire expression that we just found. So beta 1 ln x. And from here, we can easily see the beta 0 does not have an x associated to it, so that's going to disappear. So we're going to be left with the derivative of this part in here, which using what we know about the log function, this is simply beta 1 times 1 over x. So ultimately, what we have found in here is that the marginal effect, depends on x. Unlike the level model, the effect is not constant in units. It decreases when x increases, because as you can see here, this x is in the denominator. So now let's move into step 4. Let's convert to percentage change interpretation, because that was what we had. So consider a small change in x. That means that in our case, we're going to have some sort of a change in y. So our change in y is going to be beta 1 over x times whatever that small change in x that happened was. If we divide and multiply by x, then we can rearrange this simply as dy equals to beta 1 dx over x. So I'm just grouping these two together. And keep in mind, we already know by now that if multiplied basically by 100, this is the proportional change in age, and multiplied by 100, that is your percentage change in x. So what you're seeing through this is that a proportional change in x changes y by beta 1 times that proportion. Okay? Now, let's look at a special case, which is 1%. Because as you know, when we do our interpretations, we're always referring a 1 unit increase, a 1% increase in x. So what's going to happen in this case? Well, the dx over x, if I'm talking about a 1%, is simply 0.01. Okay, so what that means for me is ultimately that my dy is equal to beta 1 times 0.01, which is the same as saying beta 1 over 100. So that's the rule, that's where it comes from. So key contrasts, remember, in level, there was a constant unit effect. Level log, constant effect per percentage change. And now this model, we are assuming the same response to a 1% change regardless of the starting level of x. Okay, so let me just write that down because it's quite important. So the model assumes the same response to a 1% change regardless of the starting level of x. Reiteration, in a level log model, a 1% increase in x changes y or is associated with a change in y by approximately beta 1 over 100 units. In the next video, I'm going to show a shorter proof that you might be asked to kind of know on what we just saw in here, and then we'll move to a worked example. So stay tuned, and I'll see you in the next video.